Hi everybody. In this section we're looking at algebraic and congruence properties. Some of these properties you've seen before in algebra, and there's a couple of new ones for geometry. So the first one is reflexive property of equality, where A equals A. An example would be 25 equals 25. The symmetric property of equality states that A equals B and B equals A. So if the measure of angle P equals 90 degrees, we could say 90 degrees equals the measure of angle P. The transitive property of equality states A equals B and B equals C, then A equals C. And you can see an example for that one. The substitution property of equality states if A equals B, then B can be used in place of A and vice versa. The addition property of equality says if A equals B, then A plus C equals B plus C, so we can add C to both sides. The subtraction property of equality states if A equals B, then A minus C equals B minus C. The multiplication property of equality says if A equals B, then A times C equals B times C. The division property of equality states if A equals B, then A divided by C equals B divided by C. The last one here is the distributive property, which states A times the quantity of B plus C equals AB plus AC. And here's an example on the right for that. Okay, so those are the algebraic properties. Let's take a look at the properties of congruence. There is the reflexive property of congruence, which states segment AB is congruent to segment AB. The symmetric property of congruence states if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. And then the transitive property of congruence states if segment AB is congruent to segment CD and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. Okay, so those are all the properties we're going to be using. In example 1, we're going to solve this problem and we're going to justify each step. So on the left-hand column, we're going to show each of the steps. And the right, we're going to show the reason or the justification. So you can see the first step, we're going to distribute 2 into the quantity. So we're using the distributive property. In the second step, we are just going to combine like terms, the negative 8 plus 11. So that's our reason. And the next step, we need to subtract that 3 to both sides. That's what we're doing here. So that's the subtraction property of equality. And then we need to combine the negative 27 minus 3, which gives us negative 30. So we're just simplifying. And then we need to subtract x from the right and take it to the left side. So that's the subtraction property of equality. Now I need to combine 6x minus 5x. That's just simplify. And now I need to get rid of multiply by 5. So I'm going to divide 5 to both sides. That's the division property. And then negative 30 divided by 5 simplifies to negative 6. And that's it. There's our solution. Okay, in example 3, if the measure of angle A plus the measure of angle B is 100 and the measure of angle B is 40, prove that angle A is an acute angle. So we're going to use a 2-column proof here with the statement on the left and the reason on the right in order to make this proof. Okay, so our first statement is a given statement that we see in the problem. The measure of angle A plus the measure of angle B equals 100 degrees and the measure of angle B equals 40. So usually that first reason is always given. The second statement says the measure of angle A plus 40 equals 100. So basically, I'm just going to substitute 40 in for the measure of angle B. So that's a substitution property. Then I'm going to subtract 40 to both sides to solve for measure of angle A. That's just the subtraction property of equality for my reason. And then angle A is an acute angle. Well, 60 degrees is acute. That's the definition of an acute angle. The measure of angle A is greater than 0 and less than 90. And so now it's proven. Example 4. Write a 2-column proof for the following. Okay, so if A, B, C, and D are points on a line in the given order, and AB equals CD, then AC equals BD. So the first part of the if statement is the given and the then part is the proof statement. So let's make a sketch here. I've made a line segment with A, B, C, D on it, and I've shown AB congruent to CD. Okay, so the first two statements here are the given statements from the problem. So in statement 3, we're saying BC equals BC. Well, that's the reflexive property of equality. And then we can say that AB plus BC equals BC plus CD. Well, I'm adding BC to both sides there, so that's just the addition property of equality. Then I can say AB plus BC equals AC, and BC plus CD equals BD. Well, that's just the segment addition postulate that we learned several weeks ago. So now in the final step, we can make a substitution or use the transitive property here and say that AC equals BD. Why? Because we can put AC in for AB plus BC and BD in for BC plus CD, because in step 5 right here we know that those are equal statements. Okay, so let's take a look at this next one. I'm not giving you the statement or the reason in this, and we have to come up with it on our own. Write a 2-column proof given ray BF bisects angle ABC, angle ABD is congruent to angle CBE. Prove angle BDF is congruent to angle EBF. So I'm going to put the given statement first and label it given, and then I'm going to update the drawing. So I know that angle ABD is congruent to angle CBE, so we're going to show it there. My second statement, I could say the measure of angle ABF is congruent to the measure of angle EBC. Well, that's because of the bisector, the definition of an angle bisector. So now I'm going to label those arcs as congruent. And for the third statement, so let me adjust this. The measure of angle ABF equals the measure of angle ABD plus the measure of angle DBF. And I can also say the measure of angle FBE is equal to the measure of angle EBF plus the measure of angle CBE. And this is true because of the angle addition postulate. The fourth statement, we can say the measure of angle ABD plus the measure of angle DBF equals the measure of angle EBF plus the measure of angle CBE. Well, we just use the substitution property of equality for this. In 5, we're going to use another substitution property and say the measure of angle ABD plus the measure of angle DBF equals the measure of angle EBF plus the measure of angle ABD. Feel free to pause any of this to really kind of break down what's going on here. In part 6, we're saying the measure of angle DBF equals the measure of angle EBF. Well, that's just the subtraction property of equality. I just subtracted out the measure of angle ABD to both sides. And then that's it right there. So if we know the two measures are equal, then we know that the angles are congruent. So angle DBF is congruent to angle EBF. Because if the measures are equal, then the angles are congruent. So in this section, we're using deductive reasoning, which is a process of reasoning logically from a given statement all the way down to a conclusion, which in this case is the proof statement.